There are two features remaining to complete the candle holder: the spike used to secure the candle, and the legs with the decorative scroll work. The spike is one of the simpler features in the entire model, while the scroll is by far the most complex. The spike will be a simple revolve created on the front plane. The sketch is centered about the origin of the part using a center line. The overall shape of the spike is simple, including a 4-degree taper and a 0.01-inch radius at the top. I'll revolve the sketch and click OK. As I mentioned before, the stylized scroll work on the legs is by far the most complex feature in the entire model. Here you see a completed model. The reason this is such a complex feature is that there isn't a single feature, such as a loft or a boundary surface, that allows me to generate this geometry. Sometimes complex geometry like this can only be achieved using a very methodical and tedious approach. To give you an idea, the candle holder up to this point contains 87 features. The scroll work on the legs itself requires an additional 88 features. Because of this, it's impractical for me to show you step by step how the legs were completed. What I will do is give you an overview by using the rollback bar and highlighting some of the key steps. The completed file is also available for download, so you can review the completed model in detail. The completed part file, as well as other files used in this course, are available for downloads from the Tools drop-down menu in the Solid Professor LMS interface. The first step in creating the legs is to generate the overall shape using a solid loft feature. The shape is driven by the original layout sketch. Next comes a boundary surface establishing the outer boundary of the scroll. This again is generated using the layout sketch as a reference. The interior details of the scroll begin with an extruded surface. This was created by extruding a free-form spline sketch. To give the scroll its spiraling effect, a technique is used where the intersection of a helical surface with another surface is captured in a 3D sketch. The result is a helical 3D curve that is then extruded as a surface. At this point, you can see the framework of the scroll taking shape. What follows is a series of intricate steps aimed at capping the side of the scroll. This involves creating a ruled surface, trimming existing surfaces, as well as creating a new transition surface using a loft. Additional features follow with the goal of creating a watertight boundary that can eventually be converted into a solid. These include trim and extend features, a surface fill, and a sweep. The concept of overbuilding surfaces has been used throughout this course and is used extensively in the scroll design. This makes the process easier because it keeps you from having to build surfaces that fit perfectly. Instead, you overbuild to capture the shape of the face you need and then trim away the unnecessary areas. In addition to cleaning up the outside of the scroll, the interior must also be neatly constructed to enable the transition to a solid body. The design approach taken was to build half of the scroll. The idea being that with such a complex feature, you have to take advantage of symmetry whenever possible. At this point, the focus becomes generating the other half of the scroll. Once this is accomplished, the scroll is converted into a solid body using a surface knit feature, and then combined with the rest of the leg. A simple cut is used to grind the scroll to a flat surface. And several fillets are used to break the sharp edges. This completes the first leg. To generate the remaining legs, a circular pattern is used. Once all the legs are in place, a combine feature is used to merge the legs and the rest of the candle holder into a single solid body. Again, I encourage you to review the leg design in detail using the completed part file. Practicing this methodical approach where you take small, incremental steps toward creating complex shapes will give you confidence. The next time you're presented with a design challenge, and you don't immediately see how a SOLIDWORKS feature will help you achieve that complex shape, you'll know you can break it down and tackle it one small step at a time.